As Sally and George practice for the SATs, their scores on practice tests rise. That's nice. Let's see, let's zoom in a little bit here. We don't need to see the graphic of Sally and George. That's good. Sally's current score is 850, and it's rising by 10 points per week. Okay, let's kind of highlight that stuff. So for Sally, we got current score, and it's going up by this much per week. On the other hand, our friend George has a current score of 570, and it's growing by 50 points per week. Oh, you've seen a lot of growth there. When will George's score catch up to Sally's? Well, I think every single week his score is catching up by 40 points, right? Because the difference between them is 40. So I guess it stands to reason that eventually he will catch up with her if these trends persist. So let's see a couple ways we could take a look at this. Let's write a couple equations here. Let's do one for Sally, and we'll do one for George. So on these equations, I'm going to say x is the number of weeks that they've been taking practice exams, and y is their current score. So if I think about it, Sally's score is 850 and it's growing by 10 points per week. So basically, my rate of growth is 10 for every week, and our y-intercept, we're starting at 850. So this is an equation that we could use to model Sally's growth. George, on the other hand, his growth would look like his score, oops, at any time in the future, black pen, would be, let's see, he's growing by 50 points per week, and he has a starting score of 570. So we're wondering when these two catch up with each other, right? That one way we can approach this is just to kind of create an organized list. So if I had here, I could start with actually week 0, and then week 1, 2, 3, 5, 6, 7, 8. I don't know how far I have to go here. 9, 10. So let's see. At week 0, Sally's score, I'll do Sally, Sally, her score was 850, and then it jumps to 10 more, 860, 870, 880, 890, let's see, 900. At week 6, she would be at 910, and then at 920, 930, 940. You get the idea. Let's see, George, on the other hand, he's starting at 570, and every single month or every single week it's going to jump by 50 points. So he's going to jump from 570 to 6, let's see, add 50 to that, it'd be 620. Plus 50 should be 670, and that should be 720, and then 770, and then 820, and then 870, plus 50 would be 920. Aha! I could go another one. The next one after that should be 970. But you can see at this point we would stop because, right, Sally and George's scores are both 920 at week 7. So at week 7, they have the same score. Now, there's an alternate way that we can do this. We want to know when Sally, when her y value is exactly the same as George's y value. So what we can do is we can take this expression 10x plus 850 that we have for Sally's score and set that equal to the expression 50x plus 570, which represents George's score. And where those are equal, that's the value. That should be 7, right? We can see in our table it should be the number 7. So if I set those equations up, it looks like 10x plus 850 equals 50x plus 570. I'll go ahead and take away 10x from each side. So over here that gives me 850 equals 40x plus 570. If I take away 570 from both sides, 850 minus 570 is 280, and that's 40x. And if I divide 280 by 40, I do get that 7 is what x is. X is 7. So you can see either way, right? Either by setting their respective expressions that say what their score is at X weeks equal, right? I set the Sally part, 10x plus 850 equal to George part. And this answers the question, what value of X will make these the same? Well, when these are the same, that means they have the same score. And when X is 7, those two scores will be the same. So the last question there says, if the SAT test is in 12 weeks, who will score highest? Well, anytime for this, once we pass 7, George is the leading scorer. So 12 weeks out, George should score higher than Sally if these trends persist.